Good morning everyone. Today in this session I am going to discuss regarding the modern periodic law which was given by Moseley. Before that modern periodic law, why he gave this modern periodic law? The reason behind that is Moseley conducted the experiment. Moseley had done the bombardment of an element with that of the electron. When electrons are bombarded with an element, he observed that X-rays are emitted. The X-rays, the frequency of the X-rays, frequency is represented by nu. The frequency of the X-rays were dependent on the atomic number of an element. From this he came to conclusion that the atomic number is the fundamental basis of an element. Before that we thought that atomic mass was a fundamental base, but Moseley gave a important information that atomic mass is not important, its atomic number is important. Here he saw that the frequency of X-rays were depended upon the atomic number of an element. When he plotted a graph of square root of frequency versus Z, Z is the atomic number of an element, he saw a straight line was obtained. From this we come to know that the atomic number and frequency are related with each other. Frequency of these X-rays increases with increase in the atomic number. Hence, Moseley gave the new law known as Moseley's law or modern periodic law. Presently, we use this law is the modern periodic law. Modern periodic law, also known as Moseley's law. According to modern periodic law, physical and chemical properties of elements, physical and chemical properties of elements, physical and chemical properties of elements are periodic functions of their atomic number. This is the modern periodic law given by Moseley. The physical and chemical properties of elements are periodic functions of their atomic number. Before that, what we thought that atomic mass, we gave the Mendeleev's periodic table based upon the atomic mass, but Moseley gave a fundamental basis that atomic mass is not playing a role here, atomic number is playing a major role. Hence he changed the law. Instead of atomic weight, he modified it, the Mendeleev's law, into a Moseley's law. As a instead of the atomic weight, he modified it as a atomic number. The physical and chemical properties of elements are periodic functions of their atomic number. In the annual exam, you get for 1 mark question, define modern periodic law. Here you have to write this definition, it is for 1 marks. So based upon this theory that the periodic table, the arrangement of elements are based upon the atomic number, increasing order of their atomic number. Modified periodic law, long form of periodic table in which the elements are arranged in increasing order of their atomic number. Many modifications have been made in the present modern periodic table. What we are using is also known as long form of periodic table. This long form of periodic table in which the elements are arranged in increasing order of their atomic number. Here in modern periodic table, long form of modern periodic table was given by the scientist name known as Niels Bohr. Hence, it is also known as modern periodic table is also known as Bohr's table. This is a modified table presently we are using, long form of periodic table. In this table, the elements are arranged based upon their atomic number as well as the electronic configurations. Here the elements in its outer electronic configurations, if they are same, they are grouped together in a particular groups and they are having the same physical and chemical properties. Let us study the main features of this long form of periodic table. So, you get for 5 to 10 rupees in the bookstalls the periodic table. You have to buy that, it will be easy to understand the concept well. This is the modern periodic table or long form of periodic table which was given by the scientist Niels Bohr. This table consists of 118 elements. Here the long form of periodic table, the main features of this table is it contains 7 periods. The elements arranged in the horizontal rows are known as the periods. Here there are 7 periods present in the modern periodic table, and you can see the elements arranged in the vertical column is known as groups. The modern periodic table consists of 18 groups and 7 periods. The elements arranged in horizontal rows are known as periods. There are totally 7 periods. The elements arranged in vertical columns are known as groups. There are total 18 groups present in the modern periodic table. This is the main feature. Here these elements are arranged in increasing order of their atomic number. The elements present in one group, the same group, all these elements exhibit the same chemical as well as the physical properties. Here this complete periodic table, it is classified into 4 blocks. The first group and the second group is known as the S block elements. The 13th to the 17th group plus the noble gases is known as the P block element, and in between this S block and P block is the D block elements. From 3rd to 12th group constitutes the D block element. D block elements is also known as the transition elements. Why we call these D block elements as transition? Transition means they are having the properties of the S as well as they are having the properties of that of the P block elements. Hence we call it as a transition elements. Transition means in between. They are placed in between the S block as well as the P block elements. You can see there are 2 series present at the bottom of the periodic table. Here the first is known as the lanthanide series and next one is known as the actinide series. This is the long form of periodic table which was given by Niels Bohr. Here the S block consists of 2 groups. S block consists of 2 groups. first group and second group. Here the group 1 elements are known as the alkali elements or alkali metals. What are the group 1 elements here? Except hydrogen, here all these are alkali elements. Lithium, sodium, potassium, rubidium, cesium and francium are alkali metal. Second group are known as alkaline earth metal. Beryllium, magnesium, calcium, strontium, barium, radium. Group 1 and group 2 together known as the S block elements. Group 1, 2. Group 3 to group 12 is known as the D block elements. P block elements are from group 13 to group 18 are known as P block elements. Group 13 to 17 are P block, and the separate group it is the noble gas elements, also known as inert gas elements. Group 13 to 18 constitutes the P block elements, and D block element starts from group 3rd to the 12th is known as D block elements. D block elements are also known as transition elements, and F block elements are known as inner transition elements. Why we call these F block elements, which are placed at the bottom of the periodic table, as a inner transition elements? Because they should be placed at this position. Since these elements were discovered later on, there was no place to keep these elements, hence they place these elements at the bottom of the periodic table. Here lithium, sodium, potassium, rubidium, cesium, francium are alkali. Beryllium, magnesium, calcium, strontium, barium, radium, these are alkaline earth metals. From 3rd to 12th are known as the D block elements. If you see this 13th group starts from the boron, aluminium, gallium, indium, thallium. These elements are the 13th group elements. Since these elements starts from the boron, hence we call this one as a boron family. 13th group elements are known as boron family. 14th group elements here carbon, silicon, germanium, tin, lead. These are 14th group elements. The first element is the carbon, hence we call it as a carbon family. 15th group element nitrogen, phosphorus, arsenic, antimony and bismuth. Here the first element is nitrogen, hence we call this as a nitrogen family. 16th group elements oxygen, sulfur, selenium, tellurium, polonium. First element is oxygen, hence we call it as oxygen family. Also it is known as chalcogens. Why we call chalcogens? Means they are ore producing, hence we call it as a chalcogens. Fluorine, 17th group elements are fluorine, chlorine, bromine, iodine, astatine. Fluorine, chlorine, bromine, iodine, astatine, these are all halogens, hence 17th group elements are known as halogen family. 18th group elements helium, neon, argon, krypton, xenon and radon. These are known as zero group elements. Here why we call zero? Because its valency is 0. They are having completely filled orbital. Last orbital is completely filled. Hence we call it as zero group elements. It is having octet configuration. I have explained in the previous class regarding the octet configuration that the last shell, the valence shell is having NS2 NP6 configuration. These noble gas elements are having NS2 NP6 configuration, hence they are known as the zero group. They are also known as noble gas, inert gas. The word inert means they are less reactive. Since they are having completely filled outermost shell, hence they are very less reactive in nature. They are also known as the rare gases. In nature they are present in very small amount, hence they are also known as rare gases. Zero group elements, noble gas, inert gas, rare gas, these are all the name for a noble gas elements. I told you that in nature all the elements want to tend towards the stability. They want to attain the stability by forming a octet configuration. Octet means in the last shell it should contain the 8 electrons. So here the elements, here the hydrogen, it is want to tend towards the configuration helium, nearest noble gas configuration. If we want to write the lithium, we write the electronic configuration with respect to the helium. In this way the near inert gas is used to write the electronic configuration of that element. So this is the brief introduction regarding the modern periodic table, which is made up of 4 blocks: S block, P block, D block as well as the F block elements. Here if we see that these D block elements, here we do not study with respect to the groups, how we call it as alkali, alkaline, earth metals. Here the elements are showing the similarity in its physical and chemical properties in terms of series. They are having the similarity in terms of series, hence here D block elements are studied in terms of series. First, from scandium to zinc is known as 3D series. From yttrium to the cadmium is known as 4D series. From hafnium to mercury is from lanthanum to hafnium is known as 5D series, and the last one is from actinium and it is up to the 112 anandiyum is known as the 6D series. 3D series, 4D series, 5D and 6D series, and this 6D series, it is not a complete series, it is an incomplete series. The elements which are placed at the bottom of the periodic table is known as F block elements, also known as inner transition elements. The first series is known as lanthanide series, second one is known as the actinide series. It is also known as 4F series for lanthanide elements, and for actinide elements it is known as a 5F series. Here you have observed the word S block, P block, D block, F block. Here in the outermost shell, you know the nucleus, the outermost shell, if the last electron enters into the S orbital, then the element belongs to S block element. If the last electron enters into the P orbital, then the element belongs to P block elements. If the last electron enters into the D orbital, here after this it may be some other orbital, but the last electron if it enters into the D orbital, then it is the elements belong to D block elements. Similarly, if the last electron enters into the F orbital, then the element belong to F block elements. Total there are 7 periods and 18 groups present in the modern periodic table. Here in the competitive exams, they ask you to identify the groups. They give you the atomic number and they ask you to identify the element belonging to which group. So that you should know that groups here. 18 groups are there. Further, they are classified into A as well as B groups. This is hydrogen, lithium, sodium, potassium, rubidium, cesium is 1A. This is 1A, 2A, this is 3A scandium, 4A, 5A, 6A, 7A. After this comes here iron, cobalt, nickel. This total comes here 8th. It is not having any A. Only up to manganese is 7th A. These 3 are iron, cobalt, nickel. These groups are 8th group. After this 11th one. 11th group is known as 1B. 12th is known as 2B. 13th 3B. 14th 4B. 15th 5B. 16th 6B. 17th is known as 7th B. 7th B, and this is the 0 group or noble group, noble gas elements. You should know the A as well as the B groups. From hydrogen, this is 1A, 2A, 3A, 4A, 5A, 6, 7, 8th is there. It is not A or B. 8th is iron, cobalt, nickel, and 11th comes here 1B, 2B, 13th to 16th is 3B to 7th B, and the last one is the 0 group. In this way they are classified into A groups as well as the B groups. If you see the elements, number of elements, here the first period contains the 2 elements, hydrogen and helium. First period contains 2 elements, hydrogen and helium. N is equal to 1. 1 represents the here principal quantum number. It is having only one shell. I gave you this one. This is a nucleus. These elements are having only one shell, that is K shell. N is equal to 1. The elements belonging to the first period is having only one shell, that is K shell. N is equal to 1. N represents principal quantum number. It indicates the number of shells present in that period. N is equal to 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Here lithium, beryllium, these are having N is equal to 2. It is the second period. These elements are present in second period. Total number of elements is 8. First period is having 2 elements, that is hydrogen and helium. Second period is having totally 8 elements. Third period N is equal to 3. Third period is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. 6 plus 2. Total they are having 8 elements are present in third period. Similarly, fourth period it is having 18 elements. Fifth period is also having 18 elements. Sixth period is having 32 elements. Seventh period it should be 32, still it is incomplete, but it is here capacity will be 32 elements. If you see these two, where it will come, this 57 comes here after the barium. These 14 elements are included in the sixth period, and here this actinium to lawrencium, these elements are included in the 7th period. These two comes here. Since there is no space, they are kept at the bottom of the periodic table, and they are also showing the different properties. Hence they come as a F block elements. Here total the first period is having hydrogen and helium 2 elements. Second period is having 8 elements. Third period 8 elements. Fourth period 18 elements. Fifth here period it is also having 18 elements. Sixth 32. Seventh is also 32. Still it is an not complete here, it is an incomplete period. Seventh period is incomplete period. Here n is equal to 1, it is having the 2 elements. N is equal to 1 indicates it is having only one shell, that is K shell. N is equal to 2 indicates it is having, these elements are having 2 shells, that is K L. N is equal to 3 indicates these are having 3 shells, K L and M. Similarly, N is equal to 4 indicates it is having 4 shells, 5 indicates 5 shells, 6 shells, and maximum it is having 7 shells. N is known as the principal quantum number. It indicates the number of shells present in the elements. Here you can remember the number of elements as 2, 8, 8, 18, 18, 32, and the last is the incomplete having the 32 elements. If you see this N is equal to 1 first period, only 2 elements are there. Whether it is short period or the long period, N is equal to 2, only 2 elements are present. It is a short period. First period is a short period with only 2 elements. N is equal to 1, only 2 elements are there. First period is a short period, shortest period. N is equal to 2, second period is also short, having only 8 elements. Third period is also short period. So, first, second, third are the 3 are the short period. In that shortest period is the first one. Fourth, fifth periods, these are the long periods here. Fourth, fifth are long, even sixth and seventh is also long periods. These are all long periods. 18, 18, 32. 32 is which one? N is equal to 6. Sixth period is having 32. The last one, since it is incomplete, among these 3, if I say which is the longest period is the sixth period. First 3 periods are the short periods, and N is equal to 4, 5, 6, 7. These are the long periods. Among these, the sixth period is the longest period, and the first period is the shortest periods. This is regarding the modern periodic table. You have to buy one periodic table, you have to see that periodic table, it will be easy for understanding the concept. Here when we call it as S block means the elements, if it enters into the S orbital, last electron enters into the S orbital, the element belong to S block. In an element, if the last electron enters into the p orbital, then the element it belongs to p block elements. If the elements enter into the if the last electron enters into the d orbital, then it is the element belonging to d block elements. If the last electron enters into the F orbital, then the element belongs to F block elements. F block elements, they are placed at the bottom of the periodic table. They are also known as inner transition elements. So, here we usually name the elements up to 100, it is easy. But after 100, so after 100 what happens here? That is the 100 element is the fermium. So, 101, if you see the element name is Mendelevium. You remember in the last class I told that Mendeleus gave the periodic table. Because of his name, here they gave 101 as a Mendelevium as an element name. So, here from 101 onwards, here you can see many of the elements, they are the scientist name they have gave, and the elements after 100, they are all the elements which are not occurring naturally. They are all the elements which are synthesized in a laboratory. Hence, we call that elements which are synthesized in the laboratory are known as the artificial elements or man-made elements. The elements synthesized by the scientists, they gave their name itself. So, here official name for these elements is based upon the scientist. The scientist who discovered these elements was given the name of that element. So, here some of these elements after the are named here based upon the scientist who discovered that element. All are the those elements are artificial elements known as man-made elements because they are synthesized in the lab. In the next class, we discuss regarding these elements, that is elements having atomic number greater than 100, how to name these elements by using the IUPAC rules. What is the IUPAC? IUPAC is International Union of Pure and Applied Chemistry. Based upon the IUPAC rules, we will name the elements having the atomic number greater than 100 in the next class. Thank you.